Just a quick summary. So we learned interesting things about and interesting jargons about tough tech from Avnish. So that was a very interesting thing. And absolutely, generative AI is the new next buzzword. I also loved the whole thing about the India importance. We know how India can really produce solutions for the globe and not just for India and for the emerging markets. So that's very impressive thing which we all look forward to. There are challenges I think we all understand in Industry 5.0. There are challenges around data security, which we need to counter. There are different demands of entrepreneurs. I think that's a very interesting dimension because this is not I would say, not a simple solution to be solved. So the team and the entrepreneur would really need a complex kind of a skill set. And then absolutely the cost arbitrage is something which is not very significant. So how do we kind of manage other benefits in this would be the key. Great. So with that, we have the last panel of the evening as well, which is focused on the technology advances in the Industry 5.0. So we did hear from the last panel around the trends, around some of the investments, but this specific panel would focus more on the technology advances in the Industry 5.0 and the strength of India. On the panel, we have Rupan Alok from Pi Ventures. Rupan has 15 plus years of experience across venture capital, corporate development, and technology. Currently MD at Pi Ventures, she invests in early stage deep tech startups across diverse sectors. Prior to Pi Ventures, she invested in early to growth stage global companies at Applied Ventures. Welcome, Rupan. Along with Rupan, we have Ritu Verma from Ankur Capital, co-founder and managing partner. Ritu is the co-founder, managing partner at Ankur, an early stage fund that focuses on technology innovations for the next billion. The fund has a large focus on agtech, food, and Ritu has a keen interest in this area, especially on how technology can be leveraged to increase the efficiency and disrupt the agriculture and food value chain. Welcome, Ritu. Great. Welcome, Ritu. Welcome, Rupan.
Thank you, Siddharth.
Great. So we'll try to focus on this conversation more on some of the technology advances, what we have really seen, or where I think we really need some more innovations coming in to enable Industry 5.0. So what, from your perspective, would be the key, I would say, more hard tech innovations, something on the hardware side or something really deep tech and hard tech innovations, which need to come in to enable the Industry 5.0 revolution?
I guess I look at it as two sides of things here, right? So one is because we're talking about the digital and the data that we need. I think, we need the innovations on the computational chip side here to, if we're actually going to be like tracking everything and data goes up exponentially, our processing, et cetera, has to go through the roof as to what has to happen here. And that also sustainably, right? Since we're talking about Industry 5.0. So whether it is, quantum computing on the cloud converting to quantum computing, or whether the, chip changes on the chips into, getting better at processing the data, or whether it's new materials that the chips are being made out, whether it's graphene, whether it's gallium nitride, or, some of these kind of things. So I think from a computational perspective, the chip has to evolve if we talk about the future state that we're all envisioning here. I think the second piece, which I think is also very exciting, is, you actually need the physical materials to make this transition, right? We can talk about all we like digitally, but physically you need to make this transition. So whether you're talking about the energy transition, so whether these are better, renewable, whether you're going to the solar cells and the materials that can be much more efficient in actually creating the energy, whether you're going to batteries and talking about a much wider range of batteries for the different situations that we might have. So a whole bunch of things around that, right? So I think, let's call that energy efficiencies or energy creation or storage. But I would also just add that, if we want to talk about Industry 5.0, today we have a very, and we want to talk about this in a meaningful way on the sustainability, we've got to kind of know a little bit more about how, the actual physical emissions that we're talking about. And I think we have a very sort of broad strokes approach to it at this point of time. But if this is to be part of the core of every industry, then I think the materials for us to be able to just, if you're going to talk about sensors and emissions and we're going to get more quantitative about all of this, I think, things have to evolve there. So I think that's another area that I think, we should see more work.
So that's very impressive. I think what basically you're saying is that there's a stronger material innovation, right? It's a DX combined with maybe an MX, right? Material in transformation, which is really necessary for enabling the Industry 5.0 space. So, Rupen, from your perspective, Ritu did mention about the material transformation, which has to be the key ambition of Industry 5.0. What do you think else is needed more on the hard tech space, which will really enable this whole thing?
Yeah, of course, material science for us is also fairly important, and not just from computing perspective, but also from robotics, right? To make them better, more advanced, new sensors. So, a lot of sensors that we are currently using in IoT devices and elsewhere as well are fairly standard now. So we need to get into the next stage of innovation. So all that, I think, in terms of material science. But on the semiconductor side, I think there's lots that can be done. One of them would be in terms of, like I think in the previous panel also it was discussed, chips that are specific to AI applications, chips that are specific to edge AI, right? So how do you make this compute happen, especially in a very resource-constrained environments, which a lot of industries have that issue, right? We are talking about sensors, IoT devices, which have a very limited memory footprint, very little processing power. So can we integrate these kind of chips into such devices and do analysis on a real-time basis? So these are some of the things. I would also put AI as a very, very critical element here. And of course, when we talk about AI, it's a fairly overabused word. But when we started tracking AI, there were a lot of simple models out there. Of course, now they seem simple, but just rule-based, doing prediction, forecasting. But now there are super sophisticated models out there, right? So how do you do quality inspection using computer vision algorithms, especially in an environment where the products are on assembly line, which is moving really fast? So how do you do high-speed inference? Training. So a lot of these industries have aversion to, let's say, maybe storing data. You don't have enough historical data out there. So how do you use limited data and build sparse models which can help you give inference without compromising on accuracy? Or how do you augment whatever real world data is available? How do you augment, maybe using generative AI? But this is something that one of our portfolio companies, Switch-On, is doing, and they've been doing it for the last 2 years. Right? So these are some of the things that are happening which are really enabling our push towards Industry 5.0.
And that's very interesting because having this whole layer of AI on the very impressive hardware would be kind of the key success for Industry 5.0. When we talk of AI, I mean, how do you kind of really see the intersection between AI, automation, edge computing? What are the kind of technical advances you are seeing? You did mention something more on the kind of AI models, like Meta launched a new model on SAM. What are those advances which you are really seeing on the AI models? And what kind of innovations that is kind of leading into the hardware and more improvements on that side? Can you just maybe touch upon those?
Yeah. So if you look at AI and edge, they're not applicable everywhere, right? So they're only applicable where you have a resource-constrained environment, which we talked about, or where you really need very low latency, high-speed inference. So it is not applicable everywhere, right? So what we are seeing in terms of advancements is model compression is one of the biggest ways in which you can relatively easily get into edge computing, combining AI and edge computing. But one of the challenges there is that you might end up compromising on the accuracy because you're dumbing down the model in some ways, right? But that's one of the main ways in which we are seeing that people are able to achieve AI on edge. Second is, like I talked about, the semiconductor chips, edge AI focused chips that are coming into the market now.
Very interesting. Ritu, you have anything to share on this?
Yeah, so if you talk about AI, I think the AI into Industry 5.0, at least in our portfolio, we've seen this happening for a while, right? I mean, more than 10 years at this point, I will say. I mean, we sit on a company called Cropin that has been looking, has one of the most advanced AI in agriculture. So it's, tying in remote sensing data, using AI algorithms, so very, very complex problems, discovering land boundaries in India is a super complex problem on AI, actually, right? So, and this all goes towards sustainability because it's, talking about how land is used and, kind of what is, how things are grown, etc., right? So I would call them like, on a blockchain type stuff also, you've seen some of this happening. So I would call this this is the leveraging of AI to kind of, I think the previous panel talked about it in supply chain and leveraging it for reducing wastage or increasing efficiencies. So I think this stuff has been happening, and I think it'll become much more ubiquitous is what will happen, right? But I think the edge computing stuff that Rupan spoke about is exciting with the low latency. I was just in Bhuj and I'm very proud of this. I sold 150 tons of pomegranate in a day. Now, you see the problem on the ground, right? Like you need to grade, right? Like, so there was a machine with AI there doing it, but that whole decision making, it can just improve dramatically, right? So it's a problem where latency is not something you can deal with, right? And third, that I would just say is that AI and the next gen sort of computing for discovery of new materials. So let's just take this whole algorithm digital stuff and say, how do we find the new materials of tomorrow? I think that's actually a very fascinating space. And whether it's drug discovery, whether it's physical materials, chemicals. I mean, that's actually a really, really large and exciting space.
Oh, indeed. And I think when we talk about Industry 5.0, since our focus is very specifically on sustainability, right? When you kind of think about more computing, low latency, or making chips more stronger, more powerful, how do you kind of really see the whole power angle in this one, right? Because it'll consume more power at the end of the day, or you have more and more data centers coming in, more storage coming off the data. How do you kind of visualize the whole storage piece and more sustainability piece with all the innovations in this?
I mean, I think obviously going to green power is something, and we're invested in Off-Grid, which is a super exciting company that is sort of looking at energy storage, but energy storage with sustainable materials, right? So, I just think you need to be addressing that in a much more distributed form. And India, front in your face, throws out how this needs to be distributed, right? Like, we're not having mega centers. You need this in one center here, one center there. It's not like, here's my mega plant and I need this, right? So that the energy generation and the energy storage both need to go hand in hand for this transition, because otherwise it's a superpower consumer here, right?
Yeah, just to add, so there are also different ways in which power can be reduced at a, let's say, component level, at a device level. So for example, there are new protocols, alternatives to, let's say, Wi-Fi, Bluetooth that are coming up, which can actually reduce power consumption by a huge amount, right? And of course, these are like small things, not entire industry level, but these small things then continue to add up. So that's another way in which power can be addressed.
No, indeed. I think it has to be a mix of solutions, right? I mean, green power is one of the ways, but then how do we go at the component and system level? How do we innovate those things? I think would be the key for making it more sustainable.
Yeah, when we start doing quantum commuting and we need the AC piece over here, right? That's just,
exactly.
The power consumption there is something different, right?
True. I mean, while we're on this whole sustainable thing, how do you kind of visualize the whole circular economy piece, which is emerging in India? Because that is one of the things which even the SME sectors and a lot of even big corporates are jumping the bandwagon on. Do you see some core technology innovations happening on circular economy, be it like on plastic recyclings or other pieces of circular economy? Maybe Rupan?
Yeah, I think across the board. So just to give you a few examples, we are seeing plastics being recycled into biodegradable packaging, right? And that's not just for consumer-oriented things, but also for replacing stuff like thermocol, right? When you're transporting stuff. So that's one of the ways in which people are going into a circular economy. So one is that within the same industry, you use whatever output you're generating and recycle in some ways, right? So that becomes within the industry. An example of that would be water treatment. So in pharma, textile, right, there are a lot of effluents that are generated. Now these, either you go for zero liquid discharge or you go for treatment of this water to reuse it either in your process or maybe within the factory premises, where whatever the context is. So that's one, and there are a lot of companies, of course, a lot of old technologies like MBR, but also new stuff like electrolysis, newer membranes, from materials perspective that's coming up. Another thing is on the, which is from one industry to the other. So one industry's output becomes an input to the another industry, right? For example, battery battery recycling. So you recycle battery from, once it is approaching its end life, and extract all the metals, which you can, of course, sell it to battery manufacturers. But there are also other materials-based companies or industries that can use these metals. So these are some of the things. And of course, solid waste is a big thing in terms of taking that waste and creating something out of it, whether it is in terms of energy, biofuels, or even fertilizers.
It's interesting. I mean, what do you think are the inflection points, Ritu? I mean, we are talking of all these innovations coming in, hardware innovations in circular economy. I mean, these things are known to us from ages, right? I mean, nothing new. Why now is the right inflection point for these things? Are they like becoming more cost efficient, or more technological advances are happening?
Yeah, so can I speak about an example? And I said this. I'm a big fan of biomanufacturing and synthetic biology and sort of what can kind of happen with it. And let me just walk you through how, like the why now, and sort of how the data and all the digital innovation that we've had, coupled with biology, gets you into a circular economy and changes how we think about manufacturing, right? So biology is a pretty complex problem. I'm a physicist, so I won't even know anything about it, but it's super complex, right? So it essentially can generate data like crazy, right? I just heard yesterday that it's like Google's cloud, like a pretty large percentage of the revenue comes from DNA sequencing and processing that DNA sequencing, right? So as we get deeper into that, it's a very, very large data set that's getting produced, right? Now the cost has come down, right? The cost of all of that, the cost of both, the data and processing the data has dropped dramatically, as has creating the whatever molecule, et cetera, or whatever peptide, et cetera, protein that you want on the other side, right? So those two things bring you down to saying that, look, how can I play with a biological, like a microbe, and get it to produce something that I want, right? So the inflection here, coming back to it, is the fact that we have the computational power to be able to, let's say, understand and manipulate things for our advantage, to be mimicking. And it's a biomimicry kind of thing is what we're talking about, to make it more efficient for what we might want to produce. So you can, we're invested in this company called String Bio, which takes methane, which is a waste gas, has a bunch of microbes munch away at this methane and produce proteins. And this company is now part of something Rupan was alluding to, as to how in Western Australia there's a gas company that is setting up a full circular economy in which the waste from one goes into the other, and it's actually net zero, and you're producing different materials. So it's like it's happening because you actually can now have the control, and you can actually turn that into your advantage. And if you didn't have the data, you didn't have all of that stuff, I don't think you could be doing. You'd be mucking around a little more. It couldn't be as precise as it's getting.
That's very interesting. So I mean, we're kind of really talking of a very strong AI processing and data and insights into a very biology problem in this case. Yeah, very interesting. Rupan, anything from your...
Yeah, I think also from the customer perspective, right, from the adoption perspective, biogas has been around for a long time. Agri-waste has been lying around for a long time. Plastics have been a big problem, right? But now, over last couple of 2 to 3 years, I think there are people who are now talking about adopting these things, because one is regulation, but there are ways to go around regulations. You can get a lot of checklist technologies. But there's also, I think, some amount of genuine effort that companies are trying to make to adopt some of these things. And in the long run, I think these things can really bring about a lot of savings also for companies.
I think at the end, the economics has to really work. I mean, we can build the best of technologies. If the economics don't work, then they're kind of no use. Maybe I'll kind of request you to add one more hat on yourself, which is the venture hat now, and ask you a more different question. I know, we all love these new techs, new hardwares coming in, new kind of deep research happening. From a VC's perspective, I mean, how do you kind of ensure that these are really venture investable models? What can make you convince about such companies and innovations?
So we do have some internal frameworks that we keep in mind, but broadly speaking, when we are evaluating a company, and we do very early stage investments, right? Sometimes technology is also not completely ready. as a guiding principle for us, it's very important to keep a balance between incremental innovation. We don't do that. We also don't do core research science. So something that's being built with no business use case in mind is something that we don't invest in at all. So we look for disruptive technologies which might not be entirely ready, and but then solving a big problem which will have a global application. So that's a guiding principle that we always keep in mind when we are investing early. And of course, founders are the biggest, I think, angle in this whole story.
Yeah, and I know like we learned from the last panel as well. I think especially if you focus on Industry 5.0, this will require a very complex set of skill sets from a founder.
Yeah, I think one thing that's very important is the timing bit, right?
Yeah.
So which can be a little subjective and you can really go wrong. We have gone wrong, we have gone right also. But understanding where the technology is today, where the awareness for this technology is today, and where it was going to be 2 years down the line, right? How is it going to shift? So we actually have a framework which we've put out there and we try to map it. We are here today in 2025, this is where it is possibly going to be. And if it doesn't feel like it's moved towards aware and apparent and continues to be a hard technology, then this is a good candidate for us to invest. But if it's a technology that will become very simple, commoditized over time, then we don't invest.
And it's a difficult thing, right? I mean, when you do invest in these deep tech stuff, it's very difficult to get convinced that, hey, will they really remain niche, right? Will they really remain a strong barrier to entry on these ones? So Ritu, from your perspective, how would you kind of get convinced on hard tech startups?
So I think that a lot of the points that Rupan mentioned, right? I mean, there has to be a deep IP moat that is globally applicable, that you withstand the winds of different new technologies coming out. I would add that the scalability, like the economic commercial scalability, right? If you tell me you have to go find a mine in order for you to commercialize this, then I mean that's just too problematic for us, right? So can I, like, for example, find the ingredients that you want, like we did a protein engineering company where we spent a lot of time talking about, like, if you have to make this, like, is it all readily available, right? So you can hit the market. But I'll just add one more thing about it, right? And I think that this is an important point. As a VC, we need valuation increases as what happens, right? And we're typically used to saying, okay, look, revenue goes this way, and here's what it is, right? In the deep tech companies, it's milestones. So you have to be aware of the milestones. So there's value creation happening that's different, and I think you have to be very clear what that is. So as soon as you get fuzzy or there isn't one, then I think it's a little bit not VC investable, at least from a returns perspective as to what you want to get here.
This is very interesting, and I'm sure this is super interesting insights to the startups who are reaching out to both of you. Great. So we can take some questions now. Maybe if you have questions in the audience or online.
Hi, my name is Vikas Anvekar and I'm from Lincode Labs. We are into AI space for visual inspection for manufacturing. So my question to the panel is that with the advent of 5G in the Indian context, and also especially with the captive 5G, how do you see the lowering of dependency on the hardware, since this panel was talking about it? Where do you see this? And since more and more computing can happen over cloud because of low latency, so do you see that as something that would be a catalyst for the Industry 5.0?
So you're saying reducing the dependence on hardware because of advent of 5G? Well, if it happens, that's great, right? Because ultimately it will reduce the cost associated with doing the inference.
Maybe
but I don't know whether we are there yet.
Yeah. Are you kind of suggesting maybe we remove the edge processing kind of a need, and because of the 5G or better connectivity, we can do more things on the cloud with low latency?
Yeah, that's what. So basically, the customers now ask for more and more on-prem deployments rather than cloud-based processing, right? So with the 5G, do you think that it will be more helpful even for the AI as a whole?
Technically, yes, right? But I'm not sure that you'll have that coverage. I mean, it's a question of, I think you may need some things to just happen still at the edge, right? So you may have some initial processing, etc. But as Rupan said earlier, more more of the lighter processing, etc. I mean, I think you may still want to keep that at the edge.
I think just to add, I don't know what the implication of this would be from security and privacy perspective. If you, if it's an insecure connection, insecure environment. On edge, it is pretty localized.
Yeah, I can say this because I've seen there are specific companies, especially if you go to some of the Middle Eastern companies on oil and gas specific or any sensitive industries, they're kind of very keen on having it on the edge. They don't like things going on the cloud. And even if it goes on the cloud, they would want a localized cloud to happen, which is almost as expensive as having it on the edge or even more expensive. So your cost benefits and your advantages on scalability will be much reduced if you're having these localized clouds or on the edge.
To all of you on the panel and Sid, all you two, when you invest in a technology that has longer gestation periods, 2, 3, 4 years or even more, you are betting on the idea that the technology, the product would be competitive 4 or 5 years down the line. When there are global players who are probably also innovating, bigger global players also innovating along the same technologies, but they're far more ahead on the maturity curve. You are betting on the fact that these startups will be competitive 4 or 5 years down the line as well. How do you think through something like that? What is the framework that you usually employ to underwrite such risks?
I would disagree with your statement. So if I think that there's 30 other people doing the same thing, we don't want to be investing in that race, right? Because I mean, we're an early stage investor. We're not, deep pocketed $100 million here that, you're sort of going to compete with all of that, right? So that's where the technology has to be a differentiator. The technology has to have legs, right? The thing I worry more about is 3, 4, 5 years down the line is what's coming sideways, right? What's in a lab that takes, 5 days to sort of, displace whatever took 5 years. So it's not a race with the parallel technologies. It's more a race with what else might come out.
I totally align with what Ritu has said. So when we do our diligence, we do a full global comparative landscape because that's the last thing we want to do. Because for us, we are not looking for local maxima, right? Not just for India as a market. So there could be just 1 or 2 companies. So that's not the way to approach it. We have to look globally. And if there are people who are better, much ahead, we have actually looked at some companies and had to say no, because globally we realize that there is the companies that are way ahead in terms of technology as well as very close to customer adoption. So in that case, you just say no.
I'll kind of just slightly add on this one, Sunil. So I'll give you one example. We recently invested in a nuclear fusion company. Now you would think this is not just 2, 4 years, but it's kind of a 10-year horizon, where we believe in the success of the company coming in. The key factor for us is to understand why this would be a competitive investment is to first understand the real depth of the whole problem. So we do very deep thesis exploration, and we call it deep exploration. We understand the real nuances of what really matters in this space. What are the important KPIs, where you can differentiate each company, and then talk to all the global companies in this space to understand who could be the real king of the hill in this category. So I think the important point for me and for us is we do invest in these long-term bets, yes. The key part is how can we get more convinced that they would be a winner next 5 years or 10 years down the line by understanding some of the key parameters, what really matters, and are they really the best in this market as of now at the global level?
Yeah, hi everyone. I just have a small question. I'm a student graduating from engineering, going to graduate soon. So my question is that we know that the previous panel had talked about solar panels and we know that the previous panel have talked about solar panels and a lot of technologies related to sustainability and environmental safety. However, we know that a lot of vehicles which are lying around today still work on petrol and diesel, and thankfully few of the population have shifted to these e-vehicles. But the recent initiative by the government also is to produce 30% of ethanol and mix it with the petrol and also maybe decrease the consumption of diesel over the next couple of years. But my question is there any thought or any area where you can probably encourage more startups in the field of actually implementing on how to convert these vehicles, which are already on road, to something that's more environmentally sustainable, because that's somewhere the government has a lot of hold on, and probably that's why more students or more startups are not actually focusing on that aspect where you can actually convert what's already there into something much better. So is there any thought or perspective of yours in that area?
I can give you an example. So this was the battery chemistry company of Off-Grid that I was speaking about earlier. So while their chemistry has a lot of advantages in sort of storage and fast charging, etc., one of the use cases what they are doing is they are looking to replace the lead acid battery in a three-wheeler. Right, so it's the same three-wheelers. They have 5 or 6 of these running around at this point of time, but essentially that they found that the total cost of ownership of that, given how often lead acid gets replaced in a three-wheeler, even at whatever price points that they're predicting today without sort of massive production, makes that worthwhile. So, I mean, it's an example of how you can kind of think of repurposing, let's say, what's there as opposed to a whole new, vehicle that can then now be EV as opposed to, lead acid and diesel, basically.
Great. No, thank you. I think if we don't have any more questions, do we have something online?
Hi, this is from one of our colleagues. I think maybe it popped up at the end of the previous session, but I'll still ask it here. What is an important Industry 5.0 use case for India?
One would be ensuring worker safety.
Okay.
So especially because in our, let's say, majority of the industry in India is unstructured in a lot of ways, right? The environment is unstructured, a lot of stuff lying around. So using technology, especially AI and sensors, to ensure that worker safety is maintained, they're not going into areas where they're not supposed to be, they're following proper protocols.
Okay. Yeah, because safety was also on my mind, because we have these interacting systems when you talk about 5.0, and coming from manufacturing background, I do see a very situation there. Important. And one question from my side, you mentioned using AI for new materials discovery. So when we talk about that, so do traditionally the materials companies which have hundreds of, maybe a century of data, past chemistries, formulations, do they naturally have an edge over, let's say, a startup or an entrepreneur trying to do that? Or it'll be more, the innovation will be on the AI side of it?
So I think a couple of things out there, right? So I think these are all model based at this point of time, right? So you're coming at it with an AI and you're feeding it stuff. So it's, while they may have had chemicals or they may have had drugs or something that was like, this is just basically in the old days, you'd call this high throughput screening, right? So while they may have all of that, right? I'm not sure they actually had all the model, like they're not building the AI models for all of this, right? I mean, if you could move into, the regenerative AI part of it, or, something like AlphaFold or what, I mean, it's just a different piece. So I'm not sure that the incumbent necessarily has an edge on it, because it's coming more from the computational side of things, yeah.
I think a lot of times how these AI models work is it's not exactly a black box. They are modeled around the physics, let's say if it is about materials or the biology, how a molecule would interact with what's in the environment, right? So it's built on those fundamentals, those bare bones, and hence it will still, continue to have an edge. Of course, tribal knowledge is always a big, big advantage. And there are ways, the best thing is to combine both.
Sure. Great. So maybe I'll kind of take the last question from my side to the two panelists I have. And this is kind of more from a global perspective, which is one trend in the Industry 5.0 space, and this is more on the technology side, which really excites you the most?
For me, it's robots which are fairly advanced, can navigate in a fairly unstructured environment like a human, perceive like a human, and also grasp and manipulate things like a human.
Amazing. Amazing. That's kind of very science fiction humanoid.
No, but there's stuff. Oh, coming from someone
We
who's
have,
invested in
exactly.
agility.
In fact, I
But-
was about to mention this.
Yes, but there are companies that are working on
Yes.
these things.
I think for me, it's the intersection of biology and computation and what it can potentially do to kind of address some of the things we're talking about in Industry 5.0 from a sustainability perspective. And, is there a paradigm shift on how we, how we harness the complexity of nature and move to manufacturing in a different way?
No, I think these are two very, very interesting trends, I think, which we would absolutely be seeing much more advances in the future. So with this, I would say thank you to both the panelists. It was really interesting to have you both here. I'm sure the discussion was very interesting as well as insightful, more on the technical side. And thank you to everyone for attending this evening. Thank you, everyone.
Thank you, Sid.
Thank
Thanks
you.
for having us.